Geometry, Chapter 5, Section 3. This is side angle side congruence. So when you see throughout the week the different S's and A's, please understand that we're going to do side angle side. We're going to do angle side angle. We're going to do side side side. We're going to do angle angle, but we will never do angle side side. And I will just let you put that together. So some of you will get that. Some of you will get it later. But one of the most important words in this section is going to be the word included. Okay, so we're going to be looking at things that are included between other things. For example, in side angle side, the angle is smushed in between the two sides, which means it's included. And I'll show you what that means here in just a second. So, one of the things we do in math is we introduce something to you and we teach you how to crawl, and then we take something away. For example, we started out way back when with 6 plus 4 would equal 10. Then you got to algebra and it was 6 plus x equals 10, and then you had to find the missing thing. Still the same value, but you had to do just a little bit more work. So last chapter, or the last couple of sections, we've said that triangles are congruent if all of their sides, their corresponding sides, are congruent, and all of their corresponding angles are congruent. Now I'm going to pull just a little bit of that back. Now we don't have to have all of that information. We need just a little bit of it. Okay, so if I have two triangles, I'm just going to make a couple here real quick. Obviously, because you saw me just clone them, you know they're congruent. However, I'll mix it up a little bit just to confuse you. You're welcome. Okay. And let's say, I know, you will be totally confused. I just turned them over. Let's say this is triangle ABC, and this is triangle DEF. And if I told you that AB was 12 feet and BC was 14 feet, and then I told you that DE was 12 feet and EF was 14 feet, in the last couple of sections, we wouldn't have enough information to prove that those are congruent yet. Okay? Some of you might say, well, we could do, those are right triangles, Mr. No. We could do a squared plus b squared equals c squared and get the hypotenuse, and that's true, but how could we find the other two angles? Is there a way that you've learned so far? There is not. I can't find two missing angles in a triangle. Okay, if there's no if there's no angles over there that correspond to it that I know their values. However, these two triangles are congruent. Okay, triangle ABC is congruent to triangle DEF. And the reason is because of the side angle side congruence. Notice that we have one side that's 12 and one side that's 12, so I'll highlight those in the same color. And then we have corresponding sides of 14 and 14. And then we have this little gem right here. They both have a 90-degree angle. That 90-degree angle is included amongst those congruent sides. It is sandwiched in between. So we now have side, angle, side congruence. Okay, again, angle B and angle D, or not D, E, excuse me. Oh, that's the worst E in the world. That one's not much better. Okay, angle B and angle E are included between the congruent sides. Okay? And they have to be included. And I'm going to show you one here in just a second where they're not and show you why they are not congruent. Okay, pretty simple, right? Side angle side, equal angle, mushed in together, included in together. Okay, let's take a look at these. Now, as much as you would like to say these are congruent, because I'm going to clone them anyways, again, we have to go from the facts. Uh-oh. Oh. Okay, so let's say I have angle A, B, C, and D, E, F again. I like those three. And let's say A, B, and D, E are congruent. I'm not going to actually put numbers on them this time. I'm going to use the book congruent little marks. And then I've got BC congruent to EF. And then angle C is congruent to angle F. So my question is triangle ABC congruent to triangle DEF? Okay, how many of you think that triangle ABC is congruent to triangle DEF? How many of you think that triangle ABC is not congruent to triangle DEF? Okay, how many of you are not sure, obviously, because some of you didn't raise your hands? Okay. What do the angles have to be? Where do they have to be? No, they don't have. I'm asking location. They're already congruent. They have to be included in between. So what angles do we need to know to make this side angle side? B and E. I have to know what these angles are right here. I'm going to put just like an X there. If I knew those were congruent, that would be side angle side. Because those angles are not included, these are not congruent. Just because of the location of the angles they gave you. Now, they're not always going to give you angles. Maybe they give you a lovely parallelogram. Let's see, where's my parallelogram? There it is. And then, oh, hello, I don't want that. And then they make two triangles there. And then maybe they tell you, we'll call this A, B, C, D. Everybody sees the two triangles created, right? Okay. I've only given you one set of sides. Is there any way that you can prove that triangle ABC is congruent to triangle CDA?
Yes.
Okay. Can I find another side right away? What's another side I can find right away without knowing anything about anything? That's a side. ABCD is a side. Sides are just two letters. AC. Because they both share AC, and it's the exact same thing. AC is congruent to AC. What property is that? Reflexive property. Okay? So now, again, I probably should have stated that this is a parallelogram. Okay? So I've got two sides. Do I have any angles? No. There's no measuring. All the information is there. We just have to recall it. If I've got a parallelogram, I've got parallel sides, right? And so what is AC to the parallel sides? What's it called? Starts with a T. Transversal. So I've got a transversal that cuts through there and creates what kind of angles? Alternate interior. So isn't this angle right here congruent to this angle right here? And so now I have side, angle, side, side, angle, side, and all I gave you was one piece of information. So we have to recall all of that stuff that we've done before. Hey, reflexive property, that side equals itself. Hey, I've got a parallelogram, two parallel lines cut by transversal. I bet I'm going to have some alternate interior angles somewhere. Okay, so they may not give you everything. You may have to find some of it. So is triangle ABC congruent to triangle CDA? Yes. And if they asked you to explain, you would put because of side, angle, side. That's all you have to do. You don't have to write out some long sentence, paragraph, whatever. Okay, and all we're doing today is side, angle, side. We're going to build, and we're going to learn more. But if you're looking at it going, well, this is an angle, side, angle. We haven't done that yet. That's not going to present itself in today's lesson. All you're looking for is side, angle, side today. All right, that was just under 11 minutes and 23 seconds. So you guys enjoy.